All right, let's talk Java. If you've ever been stuck writing a messy for loop inside another for loop, you know the feeling. It gets complicated fast. Well, since Java 8, there's a much cleaner way to handle all that, Java Streams. Today, we're going to break down exactly how you can ditch those clunky old loops and start writing some really elegant, powerful code. Okay, let's just jump right in and see this in action. On the left, that's the code we've all written 1,000 times, right? A for loop, an if check. It totally works, but it's obsessed with the how. It's step by step. Now, look at the code on the right. The stream approach is all about the what. It just says, filter this, then map that, then collect the results. It's a totally different way of thinking, and we're going to walk through exactly how to get there. So before we can really appreciate just how cool streams are, we've got to understand the problem they're solving. I mean, why did we even need something better than the good old for loop we've been using forever? And this slide, wow, it really captures the chaos, doesn't it? First, there's just so much boilerplate code. All that setup for the loop and creating the new list. Then, your business logic gets all mixed in with the looping logic. It's like a tangled mess of wires. The how you're doing it completely buries the what you're trying to achieve, which makes it a nightmare to read. And trying to make this run in parallel, forget about it. It's a manual, messy, and super error-prone process. And that brings us to the big idea behind streams. It's all about a fundamental shift in how we write code. We're moving away from imperative programming, telling the computer how to do something step by step, and we're moving towards a declarative style where we just describe what we want as the end result. Okay, this is probably the single most important thing to get right about streams. A stream is not a data structure. Let me say that again. It doesn't store data like a list or an array does. The best way to think about it is like a conveyor belt. It's a pipeline for moving and processing items one by one, from a source to a destination. Once an item goes through, it's gone. You can't go back. This concept is absolutely key. So let's break that down a bit more. Like we said, streams don't store data, they're one-time use, and they're functional. But that one in the middle, lazy execution, that's the secret sauce. That's the magic. It means when you chain all your stream operations together, Java doesn't actually do anything. It just builds a plan. It's not until you ask for the final result, that terminal operation, that the data starts flowing. And this is super efficient. It means if you're looking for the first item that matches, you might not have to process the entire collection. It's brilliant. So how does this all actually work? Well, it turns out that every single stream you'll ever write follows the exact same three-stage structure. Think of it as the anatomy of a pipeline. And here's what it looks like. First, you have a source. That's where your data comes from. Then you chain together one or more intermediate operations. These are things like filtering or transforming the data. But remember that lazy execution? Nothing is happening yet. You're just building the blueprint for the pipeline. It's only when you hit it with that final terminal operation that the whole thing kicks off, the data flows through, and you get your result. So let's just lock this in. Burn this into your brain. Source, intermediate operations, terminal operation. That's the formula. It's the same pattern every single time. All right, enough theory. Let's get our hands dirty and look at how you actually build one of these pipelines with real code, starting from the very beginning, the source. The great thing is you can start a stream from pretty much anywhere. You can get one from a collection like a list or a set, from a plain old array, or even from just a bunch of static values. You can even stream the lines of a file directly, which is super powerful. But honestly, 90% of the time, you're just going to call .stream on a collection you already have. Okay, once you've got your source, you start chaining on your intermediate operations. And you can see how each step refines the data. First, we filter it down, then we find the distinct elements, and then we sort them. And here's a huge pro tip for you, something that really matters for performance. The order of your operations is critical. You always want to filter as early as you possibly can. Get rid of the data you don't need first, so the later, more expensive steps have less work to do. And finally, we get to the trigger, the terminal operation that makes everything run. Now, there are a few common ones you'll see, like for each for printing stuff out, or count to just get a number. But the absolute workhorse, the one you're going to use all the time, is collect. This is the one that takes all the elements that made it through your pipeline and gathers them up into a new collection, like a list or a set. Now, the collect method gets its real power from a helper class called collectors. The best way to think of these are like pre-built recipes for finishing your pipeline. I mean, check out that first code example. We're grouping a whole list of employees by their department in a single line of code.
Can you imagine trying to write that with loops and hash maps? It'd be a mess. Collectors just handle all that complex logic for you.
Okay, so you've got the basics down. Now let's level up. We're going to cover some of the things that really separate a beginner from an expert. The kind of stuff that's not only crucial for writing solid code, but also for totally acing a technical interview. First things first, and this is a really mature perspective. Streams are not a silver bullet. They don't replace every single loop. The real goal is always clarity. You should absolutely reach for a stream when you're doing complex data transformations and it makes the code more readable, but if you have a really simple task or you're in a super performance critical part of your code where every nanosecond counts, a plain old for loop might actually be simpler and easier to debug. It's all about choosing the right tool for the right job. And that brings up the big question, right? The one everyone asks. What about performance? What happens when I'm processing millions of items? Is this fancy new stream pipeline going to be fast enough? Well, the answer is dot parallel stream. With that one tiny change to your code, you can tell Java to unleash all of your CPU cores on the problem. It's incredibly powerful. But, and this is a huge but, with great power comes great responsibility. You can't just slap it on everything. If your data set is small, or if your pipeline is stuck waiting on the network or a database, going parallel will actually make your code slower because of all the coordination overhead. So use it wisely. It's for big, CPU-intensive tasks, and nothing else. All right, let's wrap up with 3 classic interview traps. These are the red flags that'll get you into trouble. Number 1, trying to reuse a stream. Don't do it. They are strictly one-time use. Once a terminal operation is called, that stream is closed, finished. You'll get an exception if you try again. Number 2, modifying the collection you're streaming from while you're streaming. Just no. It leads to completely unpredictable behavior. And number 3, using for each to change some variable outside the stream. That's a massive anti-pattern. Streams are meant to be functional and free of side effects. If you need to produce a result, use a proper collector. So what's the big takeaway here? Java streams are so much more than just a new syntax. They're a whole new way of thinking about processing data. They push you to stop focusing on the nitty-gritty, how, and instead to clearly and concisely declare what you want to achieve. And look, mastering this isn't just about writing prettier code. It's about writing code that's more readable, easier to scale, and frankly more modern. So the next time you find yourself about to type 4, just pause for a second and ask yourself, could this be a stream?